So, and this one's really important. This one is 6D, because this has a special case in here that I really want to make sure I talk about. So this is negative 2x minus 3y is less than 6. I still start this the same way. I go ahead and start this by solving for y. I do that by taking the negative 2x and moving it over. And when I move that negative 2x over, it becomes negative 3y is less than negative 2x plus 6. Now this is where this one gets interesting. I'm still solving for y, but to get y by itself, I have to divide everything through by a negative 3, correct? So whenever you divide by a negative, now what that means here is this now becomes y. You must change the direction of this sign. So I flip it, and now it becomes y is greater than the positive 2 over the negative 3. That becomes a positive divided by the negative becomes a negative 2/3 x, and over here the positive 6 divided by the negative 3 becomes a negative 2. Now, all right, because I changed the direction of the inequality. So inequality is an entire number line, right? So if I look at the number line goes from negative numbers to positive numbers, correct? But what happens if I divide that by a negative? If I divide that by a negative number, let's say I divide everything just by a negative 1 here. It doesn't have to be a negative 1, it could be any negative number. What happens to all of those numbers in my number line? They all flip, right? And then all of a sudden my number line is going the wrong way. That's not the way my number line works, right? So what I have to do is I have to flip it. I have to take this. All right, we're going to see if I can actually do this. No, I can't. I was going to try to flip that, but I can't. So you actually have to go through and flip it. You take this whole thing and you have to change the direction of that symbol. You know that because you see how there's a negative here? You do that whenever you divide by a negative. All right, whenever you have to divide by a negative. All right, so to go ahead and what's the next step? Step 2 is I need a table of values. So, and this is a little trick. What is the denominator of my fraction? All right, the denominator of the fraction is 3, right? So use 1, 3, and use 1, negative 3. All right, guys, I'm going to go ahead and put on pause for 1 second. Yeah. Can you unload the dishes for me as well?
Yeah.
Okay.
Oh.
The dishwasher is clean, so you can have, there's one of those probably in there. All right. Any questions on that? The reason it's not a solid line is because this symbol doesn't have the equal to portion of it, so it is strictly greater than. So if there's not the solid line, and anything, and this is always going to be true, if it is just strictly y is greater than or y is less than, those are always going to be that dashed. If it is y is greater than or equal to, or y is less than or equal to, that's when you always have the solid line. All right, so I want to make sure I taught this one because this one is always strange and it always bothers students. This one is 6E. And it's just x is greater than y. Now, there's a piece with inequalities, and I want to talk about this for a second as just an aside. If I had a statement over here, and if I said 2 was equal to A, I can flip that around, right? And say A is equal to 2. That's called the transitive property. So when we're graphing inequalities, the first step I always told you was to solve for y. So I want to flip this. So because of that, I just flip it. But when I flip it, I want to make sure that I do it correctly. So right now, the point is going towards y, and the open section is going towards x. So when I flip it, it becomes y is less than x. So go back to what we've talked about before. Think about this as the line. If I had y was equal to x, that's just a table of values where no matter what value x is, y is the same, correct? So that's what I graph. Whenever I have 1 and 1, that would be my point. If it was over here at 4 and 4, that would be my point, and it goes. And this is a dotted line because of the symbol. And one. Yes. And that's always true because there's a 1 in front of the x, and there is no number there, so the question is 0. And I'm sorry, so for the recording purposes, the question was, isn't it also true that the slope is 1 and the y-intercept is 0? So if you were graphing it using the slope-intercept point, you would graph at the origin, you go, and then you would go up 1, over 1, and then that would be your point, and then you go up 1 and over 1, up 1 and over 1 to go ahead and draw your line if you were graphing that using the slope and intercept form. All right, so which way do we shade? Because it is, the symbol is less than, go to wherever your graph is, put your pencil right on the dotted line, and less than means you go down. So from here we are shading, and we are going to go ahead and go down. So where did this come from? This over here was just the transitive property. So I was just showing you that no matter what you have, you can use this idea of going through and flipping something. So another example of the transitive property would be if I had an equation and this is just another example, if I had 5 plus x was greater than y, how could I flip that to get y first? I just take that whole equation and flip it. So that then becomes y. We just have to be very mindful that where this is saying, the point is going towards the y, and the open portion of the inequality is going around the 5 plus x. So I also have to flip that, and then that becomes y is less than 5 plus x. And then I can go ahead and change that around so I can put it in the form that I want, which is the slope intercept form of the equation.